A very warm and happy morning to you all children, and I welcome you for today's learning section. On this fresh new day, let us start a new lesson called gravitation. Children, having completed the previous lesson, we have taken up this lesson called gravitation. You may be wondering, what is this gravitation? Before going to gravitation, let me recollect what you have learned in class 8 on the topic force. So we have seen force can be defined as a pull or a push given to an object. And also we have seen what are the various effects of force. As one of the example, force causes a body to move, is one of the major cause of the force that we have discussed in class 8. Now, we will apply the knowledge of force we have studied in class 8 to gravitation here. Gravitation is nothing but it is also a type of force. Where is this force being applied? This force is applied to any two objects on the universe. So you take any two objects within our earth, or with our earth with the moon, or with the earth with the satellites. So take any two objects, there exists a force, and this force is called gravitational force. For example, if you throw a ball upward, the ball goes to some extent, and after some time it falls to the ground. Similarly, when you drop a stone from a tall building, the stone also reaches the ground. So the reason is that there exists a force of attraction between the ball and the earth, or the stone and the earth, and this force is regarded as gravitational force. Children, you would have been experienced with the story of Sir Isaac Newton and the apple. So the great scientist Sir Isaac Newton once happened to rest under an apple tree, where he noticed the apple is falling towards the ground from the tree. Einstein thought, why the apple is falling on the ground? Why not it go up? So the critical thinking of why has made him to do several experiments, analysis, and so on. And finally, he gave the idea of gravitational force. According to him, any two objects on the universe, there exists a force of attraction, whether they move or whether they are stationary. So according to Newton, when we take any two objects, for example, you take yourself and you take any object which is nearby you, say for example your book. So there exists a force of attraction between you and the book. But actually we don't feel the force. Do you feel any force of attraction between you and any nearby objects? For example, your computer, your desk, your chair, book. We don't feel the attraction. Then is Newton told something which is not ridiculous? No. What Newton said is right. We don't experience the force because the magnitude of the force is very, very less. And that we will see up when we take up or when we go in deep into the lessons. But there exists a force between any two objects in the universe. Then there arises another question. When the apple is falling towards the earth, we say the earth has a force of attraction between the apple and the earth. The earth is able to attract the apple towards it. When the earth is able to attract the apple, why not the reverse is taking place? Why not the apple attract the earth? So this is another ridiculous question. So these questions are being answered when you learn this lesson, gravitational force, in detail. So children, we will go and learn the lesson in detail in order to get the answer for these problems. Okay, we'll go now. Children, when you were in class 8, you have studied about motion and force. In turn, you have also learned that force is necessary for an object to change its position as well as to execute it in motion. Now, let us look into the picture now. You can see the raining drops, and during the rain, all the drops of water, they are being collected towards the ground. They fall towards the ground. And look at the next example to it. A set of pins from a box is accidentally fallen down. Then where do the pins go to? They also go to the ground after they fall. Now let us consider another case. Drop a stone from a height. What do you observe? The stone, which was initially at rest, starts moving towards the ground and attains a maximum speed just before it touches the ground. The stone is not moving with uniform speed. Its speed keeps changing every instant, which means that the stone is accelerating. According to Newton's second law of motion, a force is required to produce an acceleration in a body. No force was exerted on the stone. Where did the force come from then? The solution for this problem was given by Sir Isaac Newton when he saw an apple falling from a tree. His argument was that the earth attracts the apple and the apple attracts the earth. The force exerted by the earth on the apple is very large, and hence the apple lands on the earth, whereas the apple is not able to pull the earth because the force exerted by it on the earth is very small. Thus, we can conclude that the acceleration produced in the stone is due to the large force of attraction exerted by the earth, which is very, very massive. So, from the previous slide, we have concluded that Sir Isaac Newton was the scientist who gave the correct explanation for the attraction of an object which falls towards the earth. And let us learn about him. Newton was an English physicist considered one of the most important scientists of all times. Newton formulated laws of universal gravitation and motion, laws that explain how objects move on the earth as well as through the heavens. He established the modern study of optics, or the behavior of light, and built the first reflecting telescope. We have seen that Newton gave the correct explanation for the falling of an objects, and we call the force as gravitation. So what is gravitation actually? Gravitation is the force of attraction between two objects in the universe. Gravitation may be the attraction of objects by the earth. For example, if a body is dropped from a certain height, it falls downwards due to Earth's gravity. Similarly, if a body is thrown upward, it reaches a certain height and then it falls downwards due to the Earth's gravity. Gravitation may be attraction between the objects in the outer surface, attraction between the Earth and the Moon, or attraction between the Sun and the planets. So any two bodies when you take in the universe, those two bodies will have a force of attraction which is called as gravitation. And for this, you need to learn about centripetal force. When a body moves in a circular path, it changes its direction at every point. The force which keeps the body in the circular path acts towards the center of the circle. This force is called centripetal force. If there is no centripetal force, the body will move in a straight line tangent to the circular path. Now children, let us sum up what you have learned for gravitational force. Gravitational force of the earth, or simply we can call it as gravity. A force is necessary to produce motion in a body. A body dropped from a height falls towards the earth. It indicates that the earth exerts a force of attraction which is called as gravity on the body. In fact, the earth attracts all the objects towards its center. The force with which the earth pulls the objects towards it is called the gravitational force of the earth, or gravity. The gravitational force between the sun and the earth keeps the earth in uniform circular motion around the sun. The gravitational force of the earth, or gravity, is responsible for the following: for holding the atmosphere above the earth, for the rain falling to the earth, for flow of water in the rivers, for keeping us firmly on the earth, for the revolution of moon around the sun and the earth, etc. Now, let us go and analyze the law which is given by the Newton regarding gravitation. This law is known as law of gravitational constant. What is the statement given by Newton regarding this law? It's a very important statement. The universal law of gravitation states that every object or every particle attracts every other object or particle in the universe with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So this law gives the explanation and how to calculate the gravitational constant or gravitation. So he said it is a force, and this force is directly proportional to the product of their masses. If you consider m1 and m2 as the masses of two bodies, then the product of the masses is given as m1 and m2. So the force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So if they are separated by a distance r, then it is by r square, it is inversely proportional. Therefore, when you keep it up in the equation, it comes like this: F is equal to G into m1 m2 by r square, where F is the gravitational force, m1 and m2 are the masses of the two objects, r is the separation between the objects, G is the universal gravitational constant. Let us study in detail and let us derive the equation for the universal law of gravitation. The universal law of gravitation states that every object in the universe attracts every other object with a force which is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. Now, in order to understand this law, let us consider two objects, object A and object B, and let the mass of the object A be capital M or M1. Similarly, let the mass of the object B be small m or m2 as the case you have taken. Let these two objects be separated by a distance d, and let the force of attraction between these two objects, let it be F. Now, what is given in the slide we will see. Let two objects A and B of masses capital M and small m lie at a distance d from each other. Let F be the force of attraction between them. According to the universal law of gravitation, the force between the objects is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So, if we take capital M and small m as their masses, then their product of their masses is capital M multiplied by small m. So, if F is the force, F, that's what it is given, F is directly proportional to M into M. What is directly proportional to here? It is a ratio which describes the two quantities. Now, let us consider the cost of pens. Now, if I want to buy one pen, let us say it is 10 rupees. So, if I want to buy 5 pens, then I need to spend 50 rupees. So, more the number of pens, more will be the cost. So, this ratio is known as directly proportional. So, here the force of attraction increases when the product of their masses increases. That is the meaning. That's why it is said as they are directly proportional to. And the same force is inversely proportional to the square of the distance between them. And that is what it is represented. F is proportional 1 over. 1 over is the meaning of inversely proportional to d square, where d is the distance between them. Here the relation used is inversely proportional to. Now, here it represents if one quantity increases, the other quantity decreases. For example, the number of workers and the days to complete the work. So when there are more number of workers to complete a work, they will complete it in less days. So this relation is regarded as inversely proportional to. This you would have studied in your mathematics. So force is also inversely proportional to square of the distance between them. Now let us combine these two relations, directly proportional to product of their masses and inversely proportional to square of the distance. So when we combine, we have the equation F proportional to m into m by d square. Now, this proportionality sign can be replaced with equal to and a constant sign. That is what it is given as equal to G, where G is a constant. What do you mean by constant? Constant is a value where it will not change its value for any reason, anytime. And that's why we call it as a constant. Here we keep the letter G, and that is what the G is: gravitational constant, universal law of gravitation, and G is the universal gravitational constant. So when we do the mathematical calculations, we get F is equal to G into capital M into small m divided by d square. And when we calculate, it roughly comes to 6.67 into 10 to the power minus 11. So the value of universal gravitational constant is 6.67 into 10 to the power minus 11, and the unit is Newton meter square per kilogram square, and the units are taken from the formula that it has been formulated with. Children, let us see the characteristics of the universal gravitational constant G here. The expression for G is equal to F R square divided by M1 into N2, where G is the universal gravitational constant. So when we substitute all the values of F, R, M and M2, we get the value G as 6.67 into 10 to the power minus 11, and the unit for this is Newton meter square per kilogram square. Now when you look at the value, it is 6.67 into 10 to the power minus 11. What do you mean by 10 to the power minus 11? The number 6.67 is divided by 1 followed by 11 zeros. So how much will be your answer? The answer that you get is very, very, very meager, that is very small in magnitude. And that's why we don't feel the force of attraction between any two objects which are near to us. For example, if you are sitting near your computer, you and your computer should have a force of attraction according to the Newton's law of gravitation. But you don't feel this force because the force exists, but the magnitude of the force is very, very less. And that's why we don't feel it. Then the value of G does not depend on the medium between the two bodies. Suppose we are sitting in the room where the medium is said to be air. So G does not depend on the medium, whether it is air, vacuum, air, glass, it doesn't matter about it. It has the same value wherever you go. The value of G is same throughout the universe, and hence the name goes like that. Universal gravitational constant G is different from acceleration due to gravity, which is recorded by small g. Therefore, correct symbol must be used accordingly. The SI unit of G is Newton meter square per kilogram square. If two bodies of mass 1 kilogram each are separated by 1 meter from each other, then numerically G will be equal to F. Therefore, the universal gravitational constant G is numerically equal to the force of gravitation which exists between the two bodies of unit masses kept at a unit distance from each other. Now, in this slide, let us discuss about the important properties of gravitational force. Gravitational force is the weakest force in nature. Why is it weakest? We will discuss it in later. It is an attractive force. So when you take electrostatic and magnetic force, they are both attractive as well as repulsive. But here the gravitational force is not repulsive, it is only attractive. It is a mutual force. The first body attracts the second body and the second body attracts the first body with equal force. It is a central force. That means it acts along the line joining the center of the bodies. It is a mass and distance dependent. Since the formula has m and the distance d, it is dependent of these two quantities, mass and distance. It obeys inverse square law. The law which we have seen is also called as inverse square law. So it obeys the inverse square law. It is a long range force, which means it decreases with the distance as per inverse square law and becomes zero only at infinite distance, like electrostatic and magnetic force. So it is a long range of force. It does not depend on the medium between the interacting bodies. So irrespective of any medium, these two forces come into picture. Now let us discuss one of the important board question along with the importance of universal law of gravitation. So the question is, according to the universal law of gravitation, every object attracts every other object in the universe. Why can't you feel the force of attraction between you and Mars? So the question is that, so the law says there must exist a force of attraction between any two objects on the universe. If that is the case, why don't you feel the force of attraction between yourself and the Mars? So what is the answer for this? According to the universal law of gravitation, the effect of the force of gravity decreases as the distance increases. The gravitation force is inversely proportional to the radius or the distance. So the gravitational force exhibited by the Mars is not that experienced by us due to the large distance. So due to the large distance, we don't feel the force of attraction. That is the answer for this. Now let us go to the next important question. What are the importance of universal law of gravitation? Universal law of gravitation successfully explained several phenomena like the force that binds us to the earth, the motion of moon around this earth, the motion of planets around the sun, and the tides which arise due to the moon and the sun. Children, in this slide, let us see how the value of F is being affected when the masses are changing. So we have already seen that the force of gravitation is depending on the masses, product of the masses we have seen. So two masses are being taken. Now here we have taken three cases where the first case is both the bodies are having equal mass. You see to the diagram here. So the left side body has a mass m and the right side body is also having a mass m. So both of them are having equal masses. So how will be the force affected? Now in the formula, F is equal to G into m1 m2 divided by d square, you replace m1 and m2 by m itself because both of them have equal masses. So when you substitute here, then the force F1 is equal to gm square by d square. So this is the new formula for bodies which are having equal mass. Then now come to the next picture. You see to the diagram. You have the left side body, the mass is m, and the right side body, the mass is 2m. So the question will be like this: how will be the gravitational force affected if mass of one of the body is double the other? That means if you take m as mass of the first body, then when it is doubled, the mass of the second body will be 2m. Now simply substitute the values of m in the formula. So here we take it as F2. F2 is equal to G into m into 2m divided by d square. So when you simplify, you get 2g m square by d square. So when you compare it with the first one, then what happens to the force? The force is also doubled. So we can conclude when the mass of one of the body is doubled, then the force is also doubled. Now go to the last case. Here both of them are having double the masses. Both the bodies are having double the masses. So left side body, it has 2m, right side body has 2m. So substitute in the formula m1 as 2m and m2 as 2m. Now when you simplify, you get 4g into m square by d square. So when you compare it with the first one, you can see that the force is increased 4 times. So what do we conclude from this? When the masses of both the bodies are being doubled, then the force is also increased by 4 times. So this is a very important calculation based on the formulas, and this is a repeated important board question. Yes, children, similar to the previous case where we have changed the masses, now let us change the distance and see what happens to the force of attraction. Now let us take equal masses. As in the first case, equal masses, both the masses are m and m separated by a distance d. So when you substitute in the formula, F1 is equal to G into m square by d square. That is the one that you get. Now look at the second picture. Now in the place of d, you have 2d. What does it mean? The distance is doubled. When the distance is doubled, d becomes 2d. Now substitute in the formula. Now the denominator 2d square, it will become 4d square. 2d into 2d, it will become 4d square. So compare it with the previous one, F1. So we can notice that F2 is equal to 1 by 4 F1. What do you mean by 1 by 4 F1? F1 is reduced by 1 by 4 times. Okay, now when the distance are doubled, then the force is reduced to 1 by 4 of the original. So that is the result that we get after we double the distance. Now let us pass on to the third figure. What happens to the force when the distance between them is tripled or 3 times? Here the distance d becomes 3d. So substitute in the formula, the denominator becomes 3d square. When it is 3d square, then it will be 9d square. 3 square is 9. Okay, so when the distance is increased 3 times, the value of f is reduced by 1 by 9 times. So it is reduced to 1 by 9 times. So that is the result being given at the last. When the distance is doubled, the force will be reduced to 1 by 4th of the original value of the force. And when the distance is increased 3 times, the force will be reduced to 1 by 9th of the original value of the force. So from the above example, we can arrive the conclusion that force and the distance, both of them are interlinked as inversely proportional to. When the force increases, the distance decreases. And this is the value that we get when we are altering the distance. Now children, I am giving you an assignment. What will happen to the force when the distance is half? The distance become half. Then how is the force affected? This I want you to calculate, and after calculation do share it with me. Children, this slide gives you the comparison of the values of F when the masses are altered and the distance are altered. So you find the various diagrams here. Let me explain you one by one. Take the first picture. So you have equal masses m and m on left and right, and it is being separated by a distance d. Now when you calculate the force, let us say the total force is F. F is the total force when the two equal masses are separated by a distance d. So we take it as common and we compare this with all the changes in mass and changes in distance. Now let us take the first case where there is a change in the mass. So how is the mass being affected here? So left side m, right side 2m. That means the mass is doubled. So what is the result? Here it says 2f. So when the mass is doubled, the force is also doubled. Now go to the next one. Compare the masses m and 3m. The mass is increased by three times, thrice the mass. The force is also thrice. When the mass is increased 3 times, the force is also increased 3 times. You just work out and see whether you get it. And similarly, the last mass, 2m and 2m, both the masses are doubled. When both the masses are doubled, the value of the force is increased by 4 times. Now similarly, come to change in distance. So the distance in the first case is doubled, therefore it is taken as 2d. When it is taken as 2d, then it is 1 by 4f. That means the force is reduced to 4 times. Now in the second case, as I had given you the assignment, the distance has become half the distance. So when the distance is half, the answer is that the force is increased by 4 times. So the calculation part, you just work out and see whether you get 4f. And in the last case, the distance is doubled. When the distance is doubled, the force remains same. Okay, that is F itself. So calculate in all these cases the change in the force and see to it whether you get according to the slides that you have been given to you. Children, let us now go to the solution of the numericals based on the values of F and G. The first question is this: calculate the gravitational force of attraction. That means you are asked to calculate the value of F between the earth and a 70 kilogram man if he is standing at a sea level at a distance of 6.38 into 10 to the power 6 meters from the Earth's center. So here you are given with the two masses, mass of the Earth and mass of the man. So take one as M1 and the other as M2. So M1 is 5.98 into 10 to the power 24, which is the mass of the Earth, and M2 is the mass of the man, which is equal to 70 kilograms. And the distance of separation is 6.38 into 10 to the power 6 meters. So we know the G value, universal gravitational constant G, 6.67 into 10 to the power minus 11 Newton meter square per kilogram square. Now substitute all the values in the formula. F is equal to G into M1 M2 by D square. So when you substitute here and simplify, you get the answer to be 685. So children, you work out by yourself and see to it whether you get the answer by yourself. Children, by this we have come to the end of today's lesson, and there is yet another topic which has to be covered here. They are the acceleration due to gravity and free fall. These topics will be taken up next week, and by next week we will be completing this lesson, because according to the new board instruction, the another subtopic which is given as the thrust, pressure, which we have covered already, they have been eliminated for this year's portion. Therefore, we will be completing this gravitation lesson by next session. To recall what we have learned today, children, we have started with gravitational lessons. We have seen what is gravitation, and gravitation we have concluded it as a type of force, and it is exclusively an attractive force. Like the other forces, this has only a type of attraction between the objects. So any two objects on the universe, they have the force of attraction, but the force of attraction is very meager, because numerically its value is 6.67 into 10 to the power minus 11. Minus 11 meaning we have to divide 6.673 with 1 followed by 11 zeros. Therefore, the value is very meager, and that's why we don't feel the force. But massive objects like the heavenly bodies, they do, we can find a force, slight force between them. So this can be experienced between the planets. Right. Now after that we have derived an equation for the G, and we have then derived an equation for F. Then we have seen how the value of F, the force of gravitation, varies when the distance changes and when the mass changes. So these variations we have studied, and we have analyzed a problem based on this, and further to this I will be giving you the assignment, the details of the assignment and the test. I will share it in different file, so see to that file. Now children, please listen repeatedly the slides until you get understand, and that's all for today's learning, and we will meet you next week by the same time. Until then, goodbye to you children. Bye bye.